In this video, we're going to look at some of the types and properties of these triangles. Okay, so here the notation we're going to be using is we have a triangle A, B, C. There is nothing marked on this triangle. Okay, so apart from the vertices. So this is a scalene triangle. Just assume that all triangles are scalene unless otherwise. Okay, but let's have a look at some of the properties of some of the other triangles. Okay, so the one that we have to be able to spot is definitely the equilateral triangle. Okay, the equilateral triangle is a triangle whose sides are equal in length. Okay, so lines AB are equal to BC, which is equal to AC, and we mark that as this. Okay, so an equilateral triangle, what's special about it, all three sides are the same length, three sides same length. There are three lines of symmetry. One, two, three, and each angle, okay, each angle is 60 degrees. Because sum of the triangle is 180, we divide that by 3 because all the sides are the same length, and that gives us 60 degrees each. Okay, so that's the equilateral triangle. When you're dealing with parallel lines, you're definitely going to have to be able to spot those. The isosceles triangle is like the equilateral triangle, except it only has two sides that are the same length. Okay, so they could look like this, so A, B, C, where A, B equals BC. Okay, so it's the other angle that's different this time. They could look like this, or they could look like this. Okay, so there's a naming convention for these. And we really should talk about the angle, the largest angle, when we're dealing with an isosceles triangle. So in this first example, so the first triangle is an acute isosceles triangle. In the second, we're dealing with an obtuse isosceles triangle. And in the third, we're dealing with a right-angled triangle. The properties of these three triangles are the same. They have two sides the same, which means base angles, these angles that I'm marking in orange, are the same. They are all equal, and they have one line of symmetry. Okay, it's that line of symmetry that we make the most use of, and is actually what isosceles means. One line of symmetry.